Welcome to my second part of my cardiology project. This is going to involve the electrical conduction as well as the neurocardiac function of the heart. I'll be explaining it to my friend Eugene here. I figured that given that it's a little bit more heavy on the science, that it probably wasn't a great idea to try and explain it to a 9-year-old. So we'll be continuing here with the discussion. So we already learned about how the blood flows through the heart. So we have a picture of the heart here, divided into its 4 sections. The right atrium, left atrium, the right ventricle, and the left ventricle. So today we're going to be talking about how the heart can achieve something called automaticity, which is the heart's ability to pump by itself. So the first place that we'll start is where the action potential will usually propagate from, which is called the sinoatrial node. The sinoatrial node is full of what are called pacemaker cells, and the pacemaker cells are able to fire their own action potentials, which is kind of cool for a cell because not a lot of them can do that. Inside the cells, there is ions constantly going. They're flowing through and changing the voltage of the cell. So the voltage-gated channels, which are channels that will open once the cell reaches a certain voltage, are what make the action potential propagate itself, and that means move through the muscle fiber. Surrounding that is muscle tissue, which is the cardiac tissue that's going to be able to contract and pump blood. So we'll be putting the action potential through the myocytes, which are the cardiac tissue, which will allow it to contract. Continuing down, we have intranodal tracts, and we'll reach the atrioventricular node, which is another of the nodes of the heart, which is electrical pacemaker cells, so that they can propagate an action potential. Once it reaches this spot, it'll break out into 2 bundle branches, which will go down kind of like this. It has a right and a left, and we will have what are called Purkinje fibers that essentially will surround the ventricles. So once the action potential has been propagated by the sinoatrial node, it will travel through and go down to the atrioventricular node, where it has a delay so that the atria and the ventricles don't contract at the same time. And then it will continue down through the bundle blocks, through a little area here, which is actually joined. They're joined for a little bit, and then they deviate at what's called the ventricular septum. And this little bit here that they're joined for, it's called the bundle of His. And then it'll go out into Purkinje fibers, which make it so that the ventricles can contract harder, which means they can pump more blood. So that's the basic electrophysiology of the heart. It's going to start in the sinoatrial node, travel down the intranodal pathways, go into the atrioventricular node, delay for a little bit so that it can wait for those atria to contract and pump the full amount of blood into the ventricles, which will then in turn contract and send the blood off to the body. Now we also can look at this and kind of see how the neurophysiology works, which is going to be kind of 2 systems. It's going to be the sympathetic and the parasympathetic nervous system. So if you've ever heard of those, the sympathetic is going to be your fight or flight, which is going to happen when you're scared or nervous, or things come up that are making you anxious. And that's going to release epinephrine into your system, and epinephrine is going to stimulate your heart to contract harder and faster in order to pump more blood to your muscles and other systems like that would help in running or fighting off an attacker. The parasympathetic nervous system is what's called your rest and digest nervous system, and that is going to kind of slow down the heart. A lot of blood is being put into digestive areas where there's smooth muscle tissue, It's kind of, when you're relaxed at the end of the day, and that's going to be kind of calming, and that's going to use either acetylcholine or norepinephrine, which are the two hormones that would be involved in that. So, and that's basically the neurophysiology of the heart and how it works. Thanks for watching.